3D printing, also known as additive manufacturing, is a revolutionary technology that enables the creation of three-dimensional objects by adding material layer by layer, as opposed to traditional subtractive manufacturing processes that involve cutting, drilling, or shaping material from a solid block. This innovative approach to manufacturing has had a profound impact on various industries, from aerospace and automotive to healthcare and consumer goods. In this detailed explanation, we will explore the fundamental concepts, processes, applications, and future prospects of 3D printing. Fundamental concepts of 3D printing. Layer-by-layer additive manufacturing. At the core of 3D printing is the layer-by-layer additive manufacturing process. It begins with a digital 3D model created using computer-aided design (CAD) software. This digital model is sliced into numerous horizontal layers, and the 3D printer follows these instructions to build the object layer upon layer. Materials. 3D printers can work with a wide range of materials, including plastics, metals, ceramics, and even organic materials like food and tissue. The choice of material depends on the intended application, as each material offers specific properties, such as strength, flexibility, and heat resistance. Printing technologies. Various 3D printing technologies exist, each with its own set of principles and applications. Some common technologies include fused deposition modeling, FDM, stereolithography, SLA, selective laser sintering, SLS, and multi-jet fusion, MJF. These technologies differ in how they deposit and solidify materials. The 3D printing process. The typical 3D printing process involves the following steps. Design. First, a 3D model of the object is created using CAD software or obtained from a 3D scan. Slicing. The 3D model is sliced into layers using slicing software. This software generates a set of instructions, G-code, for the 3D printer, specifying how to create each layer. Printing. The 3D printer follows the G-code instructions, adding material layer by layer. This can involve melting plastic filament, solidifying resin with UV light, sintering powdered metal, or other methods depending on the technology used. Cooling and solidification. As each layer is deposited, it cools and solidifies. Some materials may require post-processing steps like curing with UV light or heat treatment. Support structures. In some cases, support structures are added during printing to support overhanging features. These supports are removed after printing. Finishing. After printing, the object may require additional finishing steps such as sanding, painting, or assembly, depending on the desired end result. Applications of 3D printing. 3D printing has a wide range of applications across various industries. Prototyping. It is commonly used for rapid prototyping to test and validate designs before mass production. Aerospace. Aerospace companies use 3D printing to produce lightweight, complex parts and components for aircraft and spacecraft. Medical. 3D printing is used in the medical field for creating custom prosthetics, dental implants, orthopedic implants, and even 3D printed organs for transplantation. Automotive. The automotive industry employs 3D printing for prototyping, customized parts, and tooling. Art and fashion. Artists and designers use 3D printing to create intricate sculptures, jewelry, and fashion accessories. Architecture and construction. It's used for creating architectural models, scale prototypes, and even construction components. Consumer goods. Customized and personalized consumer products, such as smartphone cases and eyewear frames, are produced using 3D printing. Future prospects. The future of 3D printing holds exciting possibilities. Materials advancements. Continued research into new materials will expand the capabilities of 3D printing, allowing for more versatile and specialized applications. Mass production. 3D printing is likely to become more integrated into traditional manufacturing, enabling cost-effective small batch and on-demand production. Bioprinting. Advancements in bioprinting may lead to the creation of functional human organs and tissues for transplantation. Space exploration. 3D printing may play a crucial role in space exploration by allowing astronauts to manufacture tools and parts on demand during missions. Sustainability. 3D printing can contribute to sustainability efforts by reducing material waste and energy consumption in manufacturing. In conclusion, 3D printing is a transformative technology that has the potential to revolutionize the way we design, produce, and consume goods. Its applications continue to expand, and as materials and techniques evolve, We can expect even more exciting developments in the world of additive manufacturing.